All right. So here we are doing FreeCodeCamp Legacy Python for everybody. More conditional structures, right? We're going to do the video first, and then the next one we'll do the exercise 1 and then exercise 2, just like we've been doing. All right. So let's get, actually make sure we got your notes out. Boom. We got these. And I'm going to make sure I got, come on, my logo on the screen. Boom. All right. So let's go.
So welcome back. Let's talk a little bit more.
Oh, that audio quality is terrible. If you watch the last video, you can hear anyway.
More about some more complex conditional statements that sort of build on this concept.
Okay. Let's start. More conditional structures. Let's call it this one. Let's call this one that. Actually, we're still in. I think since we're still in the same chapter, we'll just start with multi-way. Actually, we'll just watch this because we're not going to type that down. All right, so let's do this. There we go.
So welcome back. Let's talk a little bit more about some more complex conditional statements that sort of build on this concept of if and if then else. The first thing.
All right, well, let's look at this anyway. All right, so we've got multi-way. And so this is saying if x is less than 2, we'll print small. Okay, so if it is, we'll print small. Else if, and this is what elif is, it's else if x is less than 10, we'll print medium. So if it's bigger than 2 but less than 10, we'll print medium. Else we'll print large. So if it's greater than 10, so if it's like 10 or more, we'll print large, and then we'll also print all done. So that's what this is saying here. X is less than 2. No, we go this way. I guess this is a flow chart, huh? X is less than 2. Yes, print small. So it'll print small, and it won't print medium because it's just done right there. It got that done, and so it's going to come down here. All right. So it's going to either do this, or this. Let's go.
We're going to look at is the multi-way branch. And so the idea is it's kind of like the if then else, where you're going to pick one of 2, but now we can pick one of 3 or one of 4 or one of 5. And it introduces a new concept called the elif. The elif is another reserved word inside Python. And the way it works is it's probably best to look at this here, where it checks the first one, and if it's a true, then it runs that, and then it's done. It doesn't check them all. It's not like it sees that there are 2 logical conditions. It actually checks them, the first one, and how you order these matters, as we'll see in a bit. And so if the first one is true, it runs. If the first one is false and the second one is true, it runs this one and it's done. And if the neither of them are true, it falls through, and there's an else clause that is otherwise, and it runs that. So basically, it's either going to run one and then skip the other 2, or it is going to skip 1, skip 2, and then run this one. But it only runs, in this case, one of them. But the important thing is it checks these questions in order. And it doesn't check the second question until it finds that the first, it doesn't check the second question until it knows the first question is false. So if the first question is true, you're done. You're done, and you're done with this. You're done with the whole block at that point. So only one of these 3 is going to execute in that block.
All right.
So here's sort of some examples.
Let's look at it again. Oh, it's the same thing, though. Is 0 less than 2? Yes, it is. It prints this, and now it's done, right? That's basically what's going on here. Let's see.
If we, for example, have x equals 0, it's going to come down here. X is less than 2. That's true. So it runs this code, and then it skips down to that. And so it's like this, runs that code, and then skips to the end. Okay. On the other hand, if it's 5,
all right,
this is false.
Whoa, I got a job here. All right, yeah, so 5 right here, it's false, all right? So x is 5, so that's not greater than 2. I mean, not less than 2. Else if x is less than 10, so 5 is less than 10, it prints this, and then it prints this, all right? So it goes here, checks it, false, true. It checks this one, true, print it, and then you're done. That's how this goes.
And it skips that, and it checks this. This is true. It runs this code, and then it's done, skips to the end. It goes like false, true, run, end. And then if x is like 20, for example, it runs.
Oh my goodness. Pardon me. Yeah. So x is 20. Checks this. Is x less than 2? No, it's not. Else if x is less than 10. Is x less than 10? No, it's not. It's 20. And then else print large. So it's going to print large because it checks this, it's false. Checks this is false. And then this is the default. Basically, we can call this a default. Print large, and then we're all done.
It runs false, false, run the else clause, and you're done. So skip, else, run that code, and you're done. So in this case, we ran that, and we didn't run that, and we didn't run that. Again, one of them's going to run. They're checked in order. These questions are checked in order, not out of order. It doesn't look ahead. It just checks in the order that you wrote it. You're the one that wrote that order. And so there's a couple of variations on this multi-way.
Let's see what this is. All right. So no else clause. What? Oh, yeah, you can do this. All right. So x equals 5. If x is less than 2, print small. If x is less than 10, print medium. All right. So it'll print medium. But since there's no 20 here, there's no like else, do whatever. It's just going to be an if statement that just skips all the way through. And then it just prints all done. So it'll skip this because like if this is 20, if x equals 20, it'll just skip the whole thing because, it's not less than 10. And then it'll just print all done afterwards. Remember, these are all global scope. Global, local. Everything inside of this if is local. And then global again right here. Let's do it. Should we go over this? Yeah, and then right here we just you see if it's less than 20 big, less than 40, so between 20 and 39 large. Pardon me, between 20 and 40. Anyway, large, and then between anything over 100 is going to be not ginormous, but anything between 40 and 100 is huge. You get it.
Okay. You can have no else. You can have no else, as in this case, and this just means that it might not run any of them. In this case, x is 5, so it's not less than 2, but then it runs this one. But if x was like 50, for example, if x was 50, then this would be false, then it would skip, and this would still be false, and it would skip, and neither of these two would run. So if you don't have an else, you're not guaranteed that one of them is going to run, because else is like the catch-all. If the other ones are all false, then the else is the one that runs. Similarly, you can have many elifs, but this is where it's really important for you to make sure you know what order they're being taken in. So I've got, this, if this is true, it runs, it goes all the way to the bottom. If, this was, if it's false, 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 true, it runs this one and it's done. If, on the other hand, it looks at it as false, oops, go back. If it runs false, 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 they're all false, then it runs the else. Right? This one has an else, this one didn't have an else. They don't have to have them. The key is you can have more than one of these elifs. Okay? So I got a couple little things. I'll let you pause right now and look at the...
Let pause. We're pausing regardless. All right, multi-way puzzles. Which will never print regardless of the value for x? Which will never print regardless? This one or this one? Let's see. If x is less than 2, print below 2. So that will print. Okay. What? Regardless of the value for x. If x is, they're both good, right? Oh. What's wrong? Else if x is greater than or equal to 2. Print 2 or more. Less than 2, greater than or equal to 2. Oh, this one, because this is out of order, right? This is out of order. The 20 is before the 10. Is that what we're getting at?
The question is, are there, looking at the 3 lines or 4 lines of code, x equals something, are there lines of code that will never execute regardless of the value for x? And I'll let you pause and think about it, and then I'll explain it to you.
Okay, we're back.
Okay, hopefully you paused and thought about it as long as you like, but so let me now explain it to you. So we come in here, and if x is less than or equal to 2, it's going to run this first thing, and if x is greater than or equal to 2, it's going to run this, and if neither of those are true, then it's going to run this. Well, the weird thing is, all numbers are either less than 2 or greater than or equal to 2. I carefully constructed this to the point where it would never run this line of code. It is either going to run this one or run that one, but it's not going to ever run this one. So that was kind of...
What'd you say? Isn't 0? What? What'd he say?
We come in here, and if x is less than or equal to 2, it's going to run this first thing, and if x is greater than or equal to 2, it's going to run this, and if neither of those are true, then it's going to run this. Well, the weird thing is, all numbers are either less than 2 or greater than or equal to 2. I care.
What? Oh, yeah. All numbers. What?
Carefully constructed this to the point where it would never run this line of code. It is either going to run this one or run that one, but it's not going to.
Which will never print regardless of the value of x. Okay, yeah, this one definitely. So yeah, this one's pointless. Okay, that makes sense. Now, what about this out of order? I didn't have any idea that's what he was talking about. Which will never print regardless.
I ever run this one. So that was kind of like a weird dysfunctional one that I constructed. This other one is a little different. If x is less than 2, we do this. If x is less than 20, we do that. If x is less than 10, we do that. And if none of those are true, we do that. Well, the problem here is between these two lines. The problem is if something's less than 10, like 6, for example, it's also less than 20. So even though there might be values for which this is true, those also are going to have this true. So for something like 6, it's going to run here, and it's not even going to look at this. That's the point.
Okay.
It doesn't even look at this. And so that...
Okay, so yeah. I'm sure we see now he wasn't talking about this, will this not, or this not. He was talking about inside of the thing. This won't print right here, this else, because it's pointless. This elif right here is not going to print because it's also pointless. This will print, though, because there are numbers that are less than 20. I mean, greater than 20. Yeah. Anyway, let's go.
I could have made this more sensible if I'd have moved this little block of code up to there. So this is where the order in which you choose your questions, the way you put these elifs together matters, because it doesn't look at all of them. It only looks as long as it can. As long as it sees falses, then it keeps on going to the next one. But as soon as it doesn't see a false, it doesn't continue. So the last conditional structure...
All right, let's write this down. The try except... Should we have been writing these down, honestly? Should we have been writing these down? Maybe. I don't want to do the flow charts though. So let's start writing these down. I mean, it's only chapter 3. We can start now. It'd be cool. All right, let's type this thing out. Multi-way. Grab this, because I mean, this has been a video that we haven't done any kind of notes. So let's do that. Let's come down here and do multi-way. Multi-way. Multi-way conditional statements. Let's put conditional statements. Conditional statements. All right. So let's say example. And then we'll say if x, and then I tab it over, is less than 2, and then we'll have the colon. We'll do 2 tabs over and say print small. Oops, like that, and like that. And now let's copy this and paste it. All right, let's copy it like this and paste it 1, 2 times, 3 times. We've got 3, 1, 2, 3 because of the 3 prints. All right, so 1, 2, 3. Bring this down so we can see it. All right, let's change this 2 to a 10. Let's change this small to a medium. Oops. All right. Maybe I'll just do this. Still good. All right, so this 2 is going to be a 10. There's limited, really limited. Whoa. Yeah, this isn't a text editor. Medium. All right, this is going to be else. We'll say else here. And this will be large. And then we'll have huge after that. It's all caps large, arch, like that. And then we'll have all done right here. All done. And then we'll get rid of this. And we'll bring this back one. No. So that's basically the Python to do this little flow chart right here. That is X. We already went over this. All right, so let's do the next one. Same. All right. Is that all we had? Whatever. All right, so let's do this multi-way puzzle. Let's type these out. Let's grab this and say multi-way puzzle. All right. And then we'll say something like this, which will never print regardless of the value for X. All right. And then we'll come down. Let's go down 2, tab it over 1 and start right here. We'll say if X is less than 2, we will print. Don't we still have that right though? We could just do this. V. All right. So we got this. We've got 3 blocks. 2, 3 right here. Bring this one back. Get rid of this one. Print something else here. Something else. All right. Let's print right here 2 or more. 2 or more. All right. And then let's do this one. It's going to be below 2. So below 2. This is good right here. We'll change this to greater than or equal to. Greater than or equal to 2. All right. And then this one here. So let's put a comment here. This line won't run because all numbers have been accounted for. I don't know, considered in the previous 2 if statements. We could call it if blocks too, but we'll just say there. All right, and let's actually we'll do that because it is Python, and then we'll also do this like that. This line won't run because all numbers have been considered in the previous 2 statements. So there's all the numbers below 2 and then 2 and up. So this will never run. So let's write down the second one. All right. So after editing this and watching this over again, we're missing something here. So I figured we'd do that right now. So it's gonna be like this during the video, the rest of the video, but we're gonna add this to it right now. Is that it? Oh, here it is, right here. We're gonna add it to it right here. So I've got the thing right here. So what we need to do is we need to add this else. So we'll come down here and we'll say else, like this, and then we'll bring it down. And also another thing we're going to have to do, we'll tab this over one, is we're going to need to call this elif right here, right? So we'll do elif like this. And I already wrote this one down. What? I already wrote this one down here, okay? Because, you know, I do this at the towards the more end of the video. We do this, but I didn't change these ones up. Anyway, make sure that you get these right. It's going to be like till the end of the video to like correct these. Anyways, so let's let me take this out of the way and let's get back to it. And let's put some of these in between. All right, and then we'll do if x is less than 2. What am I doing? Let's take this. Let's take this, copy it from here, paste it. All right. This is cool. This is not cool. We'll turn this to 20 and we will turn this to less than. All right, print 2 more. We'll say below 20. Let's take this. Add a 0. All right. Let's take this, drop it here, turn this to 10, below 10, and then print, and then we'll do an else, print something else. Else, print something else. This line, let's take this, do Control X, and then say yes. All right, this line won't run because 10 is less than 20, because 10 is less than 20. So because 10 is less than 20, that's it. Because then 10 is less than 20, right? So this line won't run. And because this line doesn't run, that means automatically this one won't run either. All right, so there's that. Let's see, did we have anything else? Try it. Okay, let's type this stuff down now. Let's go beginning, right before we do that. All right, there we go. Now let's type this stuff down. The try except structure. The try, is that what it was? Try slash except structure. Okay. This might be something new that they don't discuss on normal FreeCodeCamp. All right, so let's do this. We surround a dangerous section of code with try and except. All right, I wonder what that means. If the code in the try works, the except is skipped. Oops, come on, there. If the code in the try fails, it jumps to the except section. I wonder what that means. All right, let's see.
Last conditional structure we'll talk about is the try and except structure. And if you know any other languages like C++ or Java or JavaScript, you're like, whoa, that's kind of an advanced concept. But it turns out in Python, because of Python's propensity to throw tracebacks in situations where you kind of would like to recover, it turns out you kind of have to use it a little more and a little earlier in your programming skill. So the problem is what if there is a line of code and you absolutely know it's going to make a traceback, it's going to blow up, but you don't want to blow up. I mean, I don't want to have code blow up. If you're using my autograder and you see a traceback in my autograder, that's kind of like, I consider that a failure. I could put an error like, hey, you entered blank data or you didn't enter a number, but a traceback, that just seems like I'm too lazy as a programmer. So we as programmers are supposed to anticipate parts of our code that are going to blow up potentially based on perhaps the user's input and then do something about it. And that's what the try and accept are for. It's you take this little dangerous piece of code that might break and might blow up, and you surround it with a try and says, this might blow up, and if it fails, run this code down here. Okay, so that's the try, and if you get an exception, the accept is kind of like if you get an exception. And the problem is if you are running code.
All right, let's see. Let's see. So cat no try.py. Okay, I guess that's the name of this. Astra. Okay, let's see what he says. Let's try seeing what this is. Okay, so this is I think this is how it's written in Apple. Okay, so Python 3 no try.py traceback. Most recent last call. File no try.py. That's this thing right here. Line 2 in module istra equals int. This one right here, yeah. Value error. Invalid literal for int with base 10. Hello, Bob. All right, because Astra is hello, Bob. Istra, you can't make an int out of this. So it comes back with the traceback. Okay, that makes sense. All right, so let's go. Let's go. Oh.
Here's a little bit of code. We put hello, Bob in, and we convert it to an integer. And we know from past experience that this blows up. Right? You can't take hello, Bob, and convert it to an integer.
Yeah, I was totally pointing at the wrong thing. But whatever. Line 3. Anyway, so this is line 3. But still, you get it.
It's just going to blow up. The problem is, and you know, here we are. It says, oh, you blew up on line 2. That's great. And I'm not very happy with hello, Bob, and whatever. But the important thing is your program stops. These other lines, they don't, oops, these other lines, they don't exist.
True.
Right? It doesn't go any further. Remember, the traceback is Python is really confused and I don't know what to do next. So Python is just going to be conservative and stop. So Python stops and your program stops. No matter how much error checking you put down here, it doesn't matter because it's gone. It's all gone. And like I said, we take this kind of personally because the code that you write is like I will tell you right now, I will never take what I do for money personally. Now, you know, if it sucks, if it really does suck, you can see all the videos I've taken down or I don't have on there. I'll take down a video that sucks, but I'm not gonna take it personally. But I guess that's just this guy's personality type. Let's go. Being put into the computer, giving it instructions. And if the code blows up, well, that sort of wipes you out. You're not in the game anymore. You're not able to do anything. So we want to be able to, especially in these situations where we can anticipate that
it's not that big a deal. It is not that big a deal. Okay? I mean, it's not that big a deal. Relax.
An error that might happen in the normal course of your program's execution might be something that you want to compensate for. And that's what the try and accept does. So here's a bit of code for the try and accept.
Hold on. Why did we just skip this whole slide? Was this just a slide just to rant on? All right. Input device, central processing unit. Yeah, we've done this. Oh, this is just to show that the code doesn't work and now something. I don't know.
Normal course or what the try and accept does. So here's a bit of code for the try and accept.
All right, let's go over this. So we've got Astra, hello Bob, try, Istra, int, accept, interest equals -1. Okay, so if this doesn't work, we'll make this -1, and then we'll print first, which will, print first is Istra. Oh, the word first. So like here, we print first and -1. And then we've got second is 1, 2, 3. Try. Do this. Istra equals int whatever. And then accept this. And then print this Istra. Okay, so this does work because, okay, this doesn't work because int, hello Bob, this string cannot be turned into an int. That's the point of this, right? So it throws -1, and -1 is, we'll see later, -1 is usually the indicator that something's wrong, okay? Because unless you're doing like real math, a -1 just means, okay, this right here is no good, all right? And then here we go. So when the first conversion fails, it just drops into the except, which is this part right here, and the except clause, and the program continues, okay? So it drops this and then it prints that. And then when the second conversion succeeds, it just skips the except clause and the program continues, okay? So this is good, skipped there. So this is a block right here. All right, there we go.
And we just have two little bits of straight line code. And so we put a string in here that's hello Bob, and then we're going to convert it to an integer. This is the dangerous code. This code in this case with hello Bob is going to do a traceback. And so we say try, and then we indent the dangerous code, and then we add this little except bit. If it works, the except is ignored. If this blows up, it runs the except. So in this code, it's going to come in, it's going to try this. This is going to blow up. But instead of giving a traceback, it's going to say, oh, I've got an available except. I'm going to run this except code, and then I'm going to continue on. And so that prints out first -1. So because we set this variable ister to -1, like a little flag telling us that something went wrong.
Yeah, a flag.
And then we keep on going. And now we have put in 1, 2, 3, the digits 123, the digits 1, 2, 3. And now it's going to work, but we still have it in a try block. And then this one works.
Remember, we can see right here, this is 1, 2, 3, but it's also in a string right here. So that's why we have to turn it into an integer. Because we could have just made it an integer to start with, but then what would be the point of this thing? Let's go.
It does not blow up, and then it ignores the except block. So the except block is only triggered when something goes wrong in the code. It is ignored if something doesn't go wrong. So it's like you bought an insurance policy on this line of code, and when things go wrong, your except block springs into action and does whatever.
My main job is directly involved with the insurance company. That's not how insurance works at all. You have to pay premiums, and you don't get the same thing that you put in. You get something worse. You just get some of the money back. You never get exactly what you put in. I hate it when people use insurance. Like, bro, that's not how insurance works.
It is that you want it to do in the case of an error. Okay, so that's a pretty useful thing. You got to be a little bit careful that you don't overuse it, because if you...
All right, let's do this. Try except. So you've got ashtray equals Bob, right? We're going to try print hello ishtray equals int ashtray. We'll print there. Okay, let's look at it. So it's going to print this. It's going to try to print this. Print hello. What's the point of that? Okay, yeah. And then istra equals int astra. So this is not going to work. It's just going to do istra equals -1. Okay. And then print done. And then istra. So ashtray equals Bob. Print hello. Yes, it does that. Can it do this? No, it can't. All right. This can't happen. But does that mean that this can't happen either? Oh, because of this? All right, it comes here. All right, it's good. It comes here. It's no good. It comes down here. Okay, so it's just going to print -1. Okay. So no matter what in this block, if any part of it's no good, it's going to throw the exception. That's basically what they're trying to say here. Let's write that down. All right, let's go here. Let's say try except. Did we have something written down on the last one too? I don't remember. Should we have done this one? Yeah, let's do it. Where's it at? No. We're not doing that. We're not writing this one down. We'll do this one. Okay, let's write this one down. They're my notes. I put what I want. All right, so let's try this. ashtray equals Bob. And let's do his dumb thing. str person equals Bob. Person equals Bob. We don't need to go crazy. Equals Bob like that. And we'll say try. Let's actually move these over to indicate that they're code. Try. And then we'll print hello. All right. And then we'll print the other, we'll do the other two also. No, we'll grab this one. Undo that. Drop it here. We'll change this person to say integer. Int changer. How about that? Int like that. We'll say int person. All right. And then we'll come down here and we'll say print there. Hello, Bob there. Why would we do that? Anyway, whatever. All right. So I'm inserting this part in right here. And I guess I'll do this so that you know. Okay. So now I'm actually editing this right now and I'm watching this and it was, what was going on? Oh, int. We can't have this saying int. Okay. The int is one of those words that this guy said we can't use because it's the name of, it's the name of this thing. Anyway, whatever. Restricted word. I don't remember what he said. Anyway, so what we're going to do is we're going to open up the notes. Is that one? Oh, that was crazy. Anyway, whatever. We'll get the notes in. You're already at that place, but I got to get there. I should. All right. So where are we? Right here. Int. Okay. So we're changing this int up. This int isn't going to be int. Let's call it this one right here. Let's call it number. Okay. That's a little bit better. Number like that. And then let's change this. Let's copy that. Get this. That's not even how we do it. Anyway, whatever. It is what it is. It is what it is. All right, so we're changing this number, but for the rest of the video, it's going to say int. But in your notes now, it looks like this. All right, look, I messed up again. See this int right here? We need to change this int as well to number. The thing is, you're not at this part. I just realized we're only right here, right now in the video. We haven't even typed this stuff in yet. Okay. Just to let you know, I caught this while editing that part in to the video. So we're here now and we're going to open up the thing again. Okay. So here versus int, let's put number. But you haven't even typed any of this stuff yet, but make sure it looks like this when you're done. When you're done looking at it. Because that's the only thing we changed. Anyway, so let's get back to it. How about doing this? And then let's get back to it. And then I'll tell you we're going to get back to it again right now. So let's get back to it like this. And go back to it. Let's say there right here. I keep forgetting about that. There. All right. And then we'll do the exception. Except, and then we'll say right here, int equals -1. All right. And then we'll do a print right here. Print, and then we'll say here, done. Int. All right. And so what this is going to do it's going to skip this stuff. Okay, so it's going to come here. We'll say this is good. Let me put this. We'll put this here. Good. This is bad. All right. And then this just gets skipped. Skipped. All right. Because this is the good one, so it would keep going to the next one. This one's the bad one, so it just skips. Goes to exception. Skipped, yeah. And then this one is ran if this one is ran if try fails. All right. And then we'll say here prints, and then what else it'll print would be done -1. Right. And like he said, this is like a flag, right? It's because if you're looking for, I don't even know, if you're looking for a person's name, right? If you're looking for this to work, it would say like hello Bob there, right? That if this thing wasn't converted into an int, right? Anyway, whatever. Let's see what he says.
One of the lines blows up, it doesn't come back to the try block. And so in this one here, we have kind of a simple, silly, more than full thing. You got to be a little bit careful that you don't overuse it, because if you put more than one line inside the try part and one of the lines blows up, it doesn't come back to the try block. And so in this one here, we have kind of a simple, silly one where we set the string. We're worried about some stuff. Well, the print statement's never going to blow up, so it's a bad idea to put it in try except anyways. Then we do this conversion, and that's the dangerous part. And in this one, it's going to blow up. And so then it's going to go to the except block and then run the except block and then continue. What it doesn't do is somehow go back and finish this. So these lines are gone. So if you look at it like this works. The try starts. Hello. This blows up. It goes to the except. It runs the except, and it continues on. Never runs that code. So it's not like you took out an insurance on the whole block. Any of those lines can blow up in the block, but whichever line blows up, that is the last line that's executing in that block. Okay? So you tend to want, in this particular example, you would probably, the print statement would go out there, and this print statement would come down here, and you would only put in your try block the single line of code that you think might blow up, because you kind of know print statements aren't going to blow up. So this is an example that's a more common real.
All right, let's type this down. So you basically said the same thing, right? All right, let's go. So what's this sample try except? Sample try except. All right. So we've got raw string equals input. And we'll put enter a number with a colon, and then cap this off like that, right? So now we're going to say try. And we'll do eval equals int raw string. That's not it. Raw string. All right, and then we'll do an except. We'll say eval equals -1. Okay. And then we'll do down here we'll do another line. If eval is greater than 0, we will print nice work. All right. And then we'll do an else here. Else we will print not a number. All right. And there we go. So we've got this. This is what would be in the console. Python try num.py, enter number 42. Nice work. Okay. Python 3. So this is the input, right? Try num.py, enter a number 42. These are the words 42, not a number. Okay. So basically, it's got this input here, and so whatever it puts in, whether it's a number or a letter or a symbol, it's going to go in there, right? And so we say try eval equals int raw string. So the raw string, like if we put a number in there, right, it'll convert the string that's a number into a integer, right? Of course. And if it's a set of words and it goes in there, it'll say, okay, this doesn't work. And so it's going to be a -1. So if eval is greater than 0, right? So 0 or more, it's going to print nice work, right? 0 or more. No, 1 or more. 0 is false. Okay, and that's another reason why we use -1s is because 0 is a falsy value. It means it's false, right? But -1 is a truthy value, even though it's a negative truthy value. Hopefully that makes sense. So if it's truthy, that's what this means right here. If it's greater than 1, if it's greater than 0, print nice work. And if it had this flag right here, not a number, right? Cool. So let's go and see some more.
Real world example where the user is going to type some data. And that's users that get us in trouble. So our program starts by asking the user to enter a number. And we know that this could be dangerous. So we're going to do it. We're going to put the conversion from string to integer in a try block. And we're going to set -1 if that's a failure. And then if it's greater than 0, we'll say nice work. And if it's less than 0, well, not a number. So first time we run this program, out comes enter a number. We type in 42, which is a string. That 42 goes back into roster, runs in here. This runs. It's fine. That becomes a 42 number. So we skip the except block. And ival is greater than 0. We print out nice work, and we skip the else. Okay? So it says nice work. On the other hand, if we run it again, this time, the input says enter a number, and we're silly. We enter the word 42, but in words, 40, F-O-U-R-T-Y. So that's a string, and that goes into roster. And then the execution continues. We run in here, and now this is going to blow up. That's going to blow up. Normally, we would see a traceback right there. There'd be a traceback. But we're not going to because we put this calculation in a try and accept block. It's going to immediately run the accept block, set ival to -1, continue on with the program. See, you are not blown up at this point. And if ival is greater than 0, well, it's -1, so we're going to hit the else clause and print out not a number. So we've done error detection. The user set something that caused a line of our code to kind of blow up, but we put that line in a try and accept block, and so we caught it. And so we dealt with that fact.
True.
So in summary, in this, we talked.
All right. So let's get this summary stuff written down. 44 minutes. All right, let's do this. We got to write these notes down, or we're not going to get it. Well, I got to do it, or I'm not going to get it. You can do what you want. Summary. So let's do that. Summary. Looks good. Yes. So there's the command operators. Comparison operators. All right. We've got double equals. We've got less than or equal. We've got greater than or equal. We've got greater than. Come on now. We got greater than. We've got less than. We've got not equals. That's not how not equals looks. This is how not equals looks. And let's put pipes in between these so we can differentiate. The pipe is shift / if you need to know. All right. Oh, and then one more right like that. That's not really better. Should I put another one in front of this? That's not better. Whatever. Anyway, so these are them. That's not better either. Whatever. It's just notes. All right, let's do indentation. Indentation. One-way decisions. One-way decisions. All right. We got two-way decisions. Okay. So this would be like an if and else. Okay. We also got nested decisions. Nested decisions. We've got multi-way. Multi-way. Come on. Multi-way decisions using elif. Okay. We've got try, except to compensate for errors. Okay, yeah. So these are the operators, of course. Indentation, it has to be indented correctly. I'm pretty sure the spaces, like when he says tabs and spaces, he just means like he wants the tab to equal 4 spaces. But I'm pretty sure that if you just tab it over or just space it over, indent it like 2 times, that's good too. I don't know. We'll see. We'll see all about indentation later. But they have to, anything on the same line, this is all the global right here, and this is the local that's indented inside of each global whatever. All right? One-way decisions is just if, or do we have any regular ifs? Well, anyway, a regular if statement. A two-way decision is, man, we should have wrote that down yesterday. The two-way decision is the if with the else. Like this part would be the two-way decision. And if this was alone, it would be a one-way decision, right? Nested decisions, we don't have any of those here right now either. But if this was, if we move this over 1, 2, 1, 2, print small, if 10 is print medium, so it would do not only this, but it would also do this, but that's dumb. All right, let's back it up. And then we've got multi-way decisions using elif. Like this stuff right here. Bro, did I not do an elif? Hold on. Did I not type the right thing? Yeah. Don't forget the elif on these ones. Good. Glad we went over this. Don't forget the elif on these ones. Elif. All right. And then right here, we would have elif. And right here, elif. Okay. So yeah, we got to remember our elifs in these elif statements. Good thing we went over the summary. And that's the multi-way decisions. And then try except, that's this stuff right here where we just try this stuff. Like if this is good, it'll print, it'll go to the next one. This is bad, so it skips. So if there's a bad one in the try and accept, it just skips the whole thing and does the exception. All right, let's listen to him talk about it. Let me get it over here. Hold on. Whoa.
Caused a line, and so we dealt with that fact. So in summary, in this, we talked about if statements, we talked about else, we talked about try and accept, how important indentation is to mark blocks where they begin and the end, and an else if and try accept. So up next, we're going to talk about loops and iteration.
All right, there we go. Great work. 50 minutes. I'm going to have to cut this up 3 times to edit it, but whatever. All right, so there's that. Now we're going to be on to exercise 1, and we'll see you next time.